I'm just going to talk over you. Okay, buddy, let's go back through the lesson today. I'm on page 493. The very first thing it says, determine whether each graph represents a function. And if we remember the vertical line test, if it passes the vertical line test, then it is. So yes, this is a function, okay? But this one's not, because it fails the vertical line test. There's more than one y value for every x value. So that's a no. And this one is a yes. It looks like maybe right here is weird, but this one's definitely a yes, because that's a x cubed, a cube root graph, okay? So what we want to talk about today was inverses. And to start an inverse, the big thing about inverses is you have to talk about switching x and y. So we'll talk a lot about this. Okay, so we have this figure, and we got all of the points, and then we took patty paper. Patty paper is like this stuff that they use for hamburger patties, right? And we put it down there, we graphed it, and then what we did, our whole lesson was if we fold this, fold it over the line, y equals x. It's really important that we fold over the line y equals x. We get a reflection. This is the inverse. And what happens is all of these points, 1, 5, this happens to be 5, 1. Negative 2, 4, this point happens to be 4, negative 2. This point at negative 1, 0 becomes a point at 0, negative 1. This point at negative 5, negative 2 becomes a point at negative 2, negative 5. Any point on the line, like negative 4, 4, negative 4, and 5, 5, those, when you flip them, they become the same point, so they are their own inverses, okay? Now, if we take a look at flipping things, and they showed this example of flipping the x's and the y's, you go from height for the y value and width for the x value. When you flip it, the height becomes the x and the y becomes width. That's all we're doing, is switching the x and y's. That's all we're doing. So then we go and take a look at this. Okay, now the problem with flipping this parabola, and you get its inverse, so every x becomes a y, and it flips like we saw before. The only problem is this is not a function, okay? So if you have a graph that when you flip it, when the flipped part graph is not a function, we'd say that the original graph does not have an inverse, okay? So we say that this graph does not have an inverse because inverse graph is not a function, okay? So again, on this one, if you switch the x and y's, this one's not a function, okay? So this is not true. You can't rotate it 90 degrees. It's not a function, okay? We also talked about power functions. So here's an x to the fourth inverse. The original x to the fourth looks like this. If you flip it, it looks like this. X to the fifth, there's its inverse. The original x to the fifth looks like this. If you flip it, look at that. X to the 6, its inverse looks like this. The original x to the 6 looks something like this. And what we find out is that if it's an even powers do not have inverses, okay? Even powers do not have inverses because their inverse graphs are not functions. So this is a no, does not have an inverse. This is a no, does not have an inverse. So if it's an even power has no inverse, but if it's an odd power, it will have an inverse. Now, I mean, look at this. Passes the vertical line test. Every x has exactly one y. And that's pretty much what we talked about, okay? That some things, if it's an even power, no inverse. Odd power, yes it will. Even power, no inverse. Odd power, yes it has an inverse. Even power, no inverse. Odd power, yes it has an inverse. Okay, and that's all I had for the day. Okay, and then we looked at graphing those as well. We came up with its original function, its inverse. We looked at all of those graphs. Okay, so that's all I had for today. Pretty easy lesson. Switch x and y's, and you got it.